Okay, so welcome to my talk. My name is Ambicomp and I'm a PhD student at the Technical University of Munich. Today I will present you some of our results from the Ambicomp research project and introduce you to the Ambicomp platform we developed during the project. Before I start, I have to give you a warning. As I got from the list of speakers, I'm the only one today coming from academia, and so maybe you will find some of the ideas I present you now a little bit crazy, so be warned. I think that's okay, and maybe you enjoy it nevertheless. Another point about my talk is that I don't speak about specific Eclipse technologies or Eclipse itself. So it's more talk about Java and bringing Java to network embedded systems. And I think it nevertheless fits well into today's program. Okay, let's start with a little motivation. We all know about existing networks of embedded systems. And I think all these systems are designed for a very specific purpose. I will give you 2 examples. You may be already familiar with them. They appear very often during such talks. The one is the automated home. There exist some prototypes of such homes. And these homes are equipped with light switches with microprocessors and entertainment systems and climate systems, which are all connected together. And the intent is to serve the inhabitants of the house well and automate things for them. Another example is the car system and all the controlling elements in the car. These are connected via a multitude of buses and networks, and work together to bring you safety to your destination. What these systems have in common is that they are closed. The systems are designed to the only specific purpose they were intended to, and you can't change a bit of them easily. What Ambicomp instead wants to provide is more a general purpose approach to embedded network systems. And for that purpose we are researching and exploring what program paradigms and infrastructure could be usable in such general purpose networks. Okay, my talk is structured as follows. I will first introduce you to the hardware we developed as part of our platform, and then give you insights about the software components. And at the end I will give you a little overview about an Eclipse-Plugin we developed to assist developers when writing applications for the Ambicomp platform, and of course a short conclusion. Okay, let's start with the hardware part. Hardware for little embedded network systems isn't new. There are a bunch of examples for such platforms. I want to pick just 2 of them. They're very popular, at least in the academic world, mostly from the field of sensor networks. These are sunspots and the scintilla per kits. You can buy them as an experimental platform, open the box, put them out, plug the battery in, and they work. They use little microprocessors, at least this one is little, it's not so little, and are executing some kind of Java environment directly on the hardware. I think the most popular example is the Squawk VM from Sun. It's a Java VM that was written to run on a hardware without any operating system. And the clue of this special version of the VM is that it's written itself in Java. Next to the software, there are some sensors and actuators directly available on such nodes, like some simple LEDs or temperature and light sensors. And you can conduct some experiments with them and let them communicate in small groups using the neck layer here of the Zigbee radio standard. Okay, Ambicomp has a little bit different approach to the hardware. We are smaller. We only use 8-bit microcontrollers, so that's very, very little. But we don't only use one microcontroller, but instead we built a modular hardware platform, so-called sandwich modules. And you can combine the sandwich modules, like you can see here, over there, in a stack. Some of the sandwich modules are equipped with an 8-bit microcontroller, some aren't. And all the ones equipped with the microcontroller execute the Ambicomp virtual machine. I will talk later about this specific part of the project. As you can see, you are free to build whatever node you like. You can choose from a variety of sandwich modules and combine them, and then you get a node. The node can have general purpose I/O, like you can see here, or Ethernet, or some other communication channels. And the boards equipped with a microprocessor are also equipped with a little BIOS. This is so little that it fits in the bootloader section of the 8-bit microcontroller, so it's near nothing. The only purpose is to get the same VM running on all the microprocessors. Okay, the power supply can be achieved by power over Ethernet, for example. So in contrast to the examples I presented you before, this is very well suited for experimental environments like your lab.